this is the energy efficiency improvement opportunities in lighting system. That what are the necessary steps which we should take, what replacement are required so that the energy saving can be done as far as lighting system are concerned. So we will focus on this. First and foremost is the fact that we should try our best to use the natural light as far as possible. Okay. Next is that nowadays there is also greater usage of sensor technologies. The important sensor is the occupancy sensor, so which can sense that if there is no one present in the room or the office, it will switch off automatically. Okay, so that should be installed for the effective energy saving. Next is the tube lights, which we used to purchase and use in earlier days. That tube light is T12 tube light. Okay, so this T12 refers to the diameter in 1 by 8 inch increment. So this T12 means 12 by 8 inch or the 3.8 centimeter diameter tubes. So they were having poor efficiency, lumen depreciation was there, lamp life was also less, color rendering was also there, problem was there. So replacing that by the T8 lamps, it improves the efficiency in 1:2, or you can say that it is doubly efficient than the T12 tube lights. Then if we replace the mercury lights by the metal halides or the high pressure sodium lights, it's again good, because when the color rendition is critical, rendition we mean the performance. Okay, so when the performance is affected by the color, these metal halides can replace the mercury or fluorescent lamps, and also there is energy saving of 50%. Mm. And when the color rendition or its performance is not critical, then we can use the high pressure lamps, and again it offers the energy saving up to 50 to 60% as compared to mercury lamps. So what do you mean exactly by the color rendition or the color performance is that, for example, if we take the example of any jewelry showroom who are dealing with gold. So if they are dealing with gold, so as and when the customers are coming to them, they will show their products, whether it is rings or whether it's anklets or whether chain, etc. So the natural color of the gold is somewhat yellow or brown. So if the showroom owner is using that metal halide lamps or any other lamp which is having the same color or the yellowish outlook lamp, so it will add value to its products. Similarly, if the jewelry businessman is dealing with the silver products, so silver is by default white in color, so it is advisable for him to use more white tube lights or LED tube lights of white color, so that their jewelry products, especially silver jewelry product, is more reflecting, so that he can sell them easily. So this is the concept behind this. Similarly, if we replace the metal halide with the high intensity fluorescent lights, it is good. And high efficiency fluorescent lamps includes the electronic blasts, high efficiency fixtures, because you must have observed that earlier we used to have the in tube lights we used to have choke, magnetic choke and starter system. So that was not good enough. So same is the performance efficiency which affects here as well. So so the advantage of the new system here is that there is low energy consumption, lower lumen depreciation, that the illumination which is responsible for lighting the office space or the industries, so that does not dips, because otherwise if we see CFL, the CFL is affected by aging. If your CFL is working for 2 years, although it has the guarantee of 1 year, if it is working for 2 years, then if you switch on the CFL, then it will take say 15 to 20 seconds to illuminate to its 100% potential. Okay, so that problem is also avoided here. So there are better dimming options, faster startups, color ignition is there, and it is also good for the eyes. It will does not have the glare, less, it has the less glare. Okay, so these are the advantages which are associated with the uh, high intensity fluorescent lights. Next is the magnetic blast and the electronic blasts. So here we can say that the electronic chokes which we use nowadays are far more effective than the this system which was earlier, which was based on the magnetic blast. So you can say that those magnetic blasts used to regulate the voltage, and tube light or bulb receives that voltage so that that does not overheat or explode. So it was based on that principle. But in case of the electronic blast, after the flow of the electricity by the series of the induction coils, okay, so they can alter the flow of electricity by the series of induction coils, and it can change the frequency without the change in the voltage. So this is the good thing about it. Okay, and frequency range is also very large in this case. So flickering problem is also not here in this case. So it again, electronic blast result in the saving of 12 to 25%. So that is very good. Then the design of the plants. So the design of the plant should be such that the natural light comes easily to the plant, so that there is minimal use of the artificial lighting system. And for example, if we see, can say the ceiling part, or in case sometimes we can say the reception area. So that can be uh, designed in such a way using the ventilators or the overhead sheets, so that the natural lights can enter. Okay, so and the natural light also affects the energy saving. Next topic is the energy efficiency improvement opportunities in the steam system. So broadly, we can say that the steam systems are generally found in the textile plants, and in electrical power generation, where there are boiler systems and general generators. We are here talking of the thermal power plants. Okay, so which prominently use coal, and that coal is fired, then water is turned into steam, and that is used. Okay, same steam can be generated using the nuclear power plants. So in the electrical power generation, gas power plants, again it uses the gas as a fuel, but the steam is generated, and the rest of the process is same. So the how can we best utilize this steam generation and its operation? First of all, that the boiler should be efficient in the high fire setting. Okay, so in the high fire setting, we means that if the demand is more, then that boiler can generate large amount of steam. And the problem which is associated with is that all the boilers are generally oversized, because at the time of the planning of any boiler or any textile industries boiler, so it was based on the fact that the in the future we are going to have plant expansion, or we are going to have more power generation, so we will require more power, and that will require more steam. So the boilers are oversized. So when they are oversized, then uh, and if it is not used to its full efficiency or the full load, then its output will be less. Okay, so uh, the common problem with the oversized boiler is the short cycling. So short cycling which occurs that when the boiler quickly satisfied the heating demands and shut downs again. Okay, so if the it is based on good efficiency boilers, so it will uh, boil easily in less time. Okay, but it is not meant for that. Okay, so that is the case. So the fuel saving can be achieved by adding the small boilers. Okay, so if we are having the small boilers, so that can be the best option under the present circumstance. Okay, so the operation measures to operate the boilers on the high fire setting, having the average payback time of 0.8 years, and the installation smaller boilers is having the payback time of 1.9 years. Okay, so this is the payback period which is associated with the boilers. Next is the boiler allocation control. So in this, we should have the multiple boilers, and the proper boiler allocation should be there where, depending upon the demand, and automatic controllers should be there, which can regulate the fuel or regulate the steam generation using the automatic flow valves. So that is the good option of energy saving. Next is the flue shut off dampers. So when boilers are regularly shut down due to the load changes, the heat is lost to the chimney can be significant. Okay, so a solution to stop this is the loss of hot air is to fit fully closing stack dampers, which only operate when the boiler is not required. Okay, so it emphasizes the point that if we are frequently switching on and off the boilers, then the heat is lost through the chimney, and the boiler is cooled down, and when we are required to restart it, then we are again required to go for the combustion and heat up those boiler to again rising temperatures to use it effectively. Okay, so here the proper boiler allocation systems is to be taken care of. Next is the maintenance. The burners and the condensate return system go for the wear and tear, so that should be mm, maintained frequently. It also happens in our uh, domestic applications also. Next subtopic is the reduced fouling. So what happens in the boiler tubes, the from the inside, and the inside there is a scale formation. So that is due to the chemicals and different salts present in the water. So what that does, that it reduces the efficiency of the steam production. And from the external side, there is the formation of soot. So what is the soot? The soot is the carbon black layer. Okay, so when that carbon black layer uh, formation is there, it is approximately of 0.8 mm. So when it reaches 0.8 mm, the heat transfer is reduced by 9.5%. And similarly, if it reaches 4.5 mm, the heat transfer is reduced by 69%. So it can be, it should be regularly maintained and removed. So sooting is the big problem. And the scale deposition, as I have just mentioned, that calcium, magnesium, and silica are the common chemicals which are there. So these water tube boilers and fire tube boiler, these are the two main boilers where the problem of the scaling occurs. So it can be removed by the mechanical means, by abrasion, mechanical abrasion, or by the acid cleaning, whatever suits us. Okay. Uh, Next is the optimization of boiler blow down rate. So this is the lead the how can we best possible uh, go for the heat recovery. Okay, so this waste energy, waste water, or the condensate, before we go for its exit mode, we should tap its heat. Okay, same is the case with the flue gases. When these flue gases are leaked from the boiler, or so whatever there is exit path, before going for its exit path, or whether it is through the uh, chimney or whatever the case may be, its heat should be trapped before that. Okay, so next is the reduction of the excess air. Although the air is required for the complete combustion of the coals, but if the air is slightly in excess of the ideal stoichiometric ratio, which is the fuel oblique air ratio, is required for the safety, it helps in reducing the nitrogen oxides emissions. Okay, so this is to be taken into account. Flue gas monitoring I have just mentioned. So next is the economizer. So heat from the flue gases can be used to preheat the boiled water in an economizer. Okay, so this is the you can say the instrument which is used for heat recovery. So the recovery from the condensate and blow down I have just mentioned. So the best possible method is to use the combined heat and power plants, or this the cogeneration. So it helps in the tapping the heat, so that that heat can be used to boil or at least raise the temperature of the water, so that the steam generation can be achieved in less time and with the less fuel consumption. So this is the method, CHP method, or the combined heat and power method, which is used.